Multiple bonds appear in Lewis structures as a result of which of the following phenomena? A. An excess of electrons available after single bonds have been formed between the central atom and the surrounding atoms in all atoms, except hydrogen. Octets have been completed. B. A deficiency of electrons available after single bonds have been formed between the central atom and the surrounding atoms in all the atoms, except hydrogen. Octets have been completed. C. The number of electrons available equals the number of electrons that are used to form single bonds between the central atom and the surrounding atom in all atoms, except hydrogen. Octets have been completed. Or D. None of the above. To answer this question, we must review the steps in drawing a Lewis structure for a molecule. First, count the s and p electrons of all atoms in the molecule to get the number of electrons you have to draw the structure. Account for charge if drawing a Lewis structure of an ion to get the number of electrons you have. Add 1 electron for each negative charge. Subtract 1 electron for each positive charge. Next, draw the preliminary structure by placing the least electronegative atom in the center, attaching the surrounding atoms with single bonds, and completing the octet of every atom in the structure with lone pairs, so every atom is surrounded by 8 electrons. Hydrogen is an exception to this rule, as it will only have the 2 electrons from the bond surrounding it and will never have lone pairs. Finally, count the electrons in the preliminary structure to get the number of electrons you have used in this preliminary structure. If the number of electrons you have is equal to the number you have used, the preliminary structure is correct, as drawn and only has single bonds. Double bonds only come about when the number of electrons the molecule has and those used in the preliminary structure are different. Now we'll determine in what case multiple bonds are needed to complete the Lewis structure. First, we'll look at what happens when we draw a double bond between 2 atoms where there only is a single bond. Let's look at 2 oxygen atoms joined by a single bond. Notice that each oxygen is surrounded by 3 lone pairs, in addition to the single bond to complete their octets. We'll now place a double bond between them. We count and see that this structure for diatomic oxygen uses 14 electrons. Now we'll add a double bond between the 2 atoms. But we must maintain each oxygen atom's octet and erase a lone pair from each of the atoms. If we recount the electrons on the molecule now, we'll see that we have used 12 electrons. Therefore, a double bond between 2 atoms uses 2 less electrons than a single bond. So a double bond would conserve electrons if the preliminary structure uses too many. Therefore, the correct answer is B. If the preliminary uses too many electrons, then the molecule is deficient electrons to contain only single bonds.